Hi guys, we're just going to deal with our horizontal translation at the moment. Okay, so what we've got is we've got our period, okay, 0 to 2 pi. But what you notice is if you look at our graph, remember that our period was dilated, okay, from the x-axis, so our period was half. So I actually get more solutions than what we actually started with. Okay, so what we need to do is we need to manipulate our domain to know how many answers that we can get. Okay, how we do that is simply putting this function, okay, this top part of here, and we're going to put it into that domain. Okay, we're going to put it into the domain. What I'm going to do first is I'm going to put the 2x into this. Okay, so I'm going to multiply my largest and my minimum, so my max and min vary by 2. Okay, so what this becomes is 4 pi, and this lowest value still becomes 0. Okay, 2 times 0 is still 0. What I'm going to do now is I'm going to go 2x plus pi on 2. So I'm going to add pi on 2 to each of these. So I've got 4 pi. If I'm adding pi on 2, that becomes 9 pi over 2. And my minimum becomes pi on 2. So what we need to do is we need to find all of our values within this domain. Okay. So to find our x-intercepts, okay, so x-intercepts, we're going to let y equal 0. Okay, so 0 equals minus 3 sine bracket 2x plus pi over 2. Okay, 0 divided by negative 3 is still 0. Okay, so that doesn't change. So what I'm actually going to do is when I bring sine to the other side, I'm actually finding inverse sine. I'm going to move the variables there on the left hand side, so 2x plus pi over 2. And on this side is going to be sine minus 1 of 0. Okay, referring to your exact values, the sine of negative 1, you match up the columns with what locations you get, okay? And what we do, so when we draw our unit circle, okay, so drawing our unit circle around, sine represents the height, so our starting point is there. That's our first value. But if you notice within our domain, that is not one of the values that we're going to use, okay? So what I'm going to do is I'm going to move across to pi, and pi actually fits within this domain that we've changed now. So my first value will be pi, and then I'm going to constantly move around. So I'm going to go all the way across. Okay, 2 pi is within that, so 2 pi, comma, we're going to go around again, okay, to 3 pi, go around one more time, and we get 4 pi. Okay, if we go around one more time, I've got 5 pi, which is outside of my maximum domain, so I'm just going to stop there. So those are my values, and this is still equal to 2x plus pi over 2. Okay, so what I'm going to do is I'm going to rearrange this equation. I'm going to subtract pi on 2 from each one of those coordinates that we have. So this becomes 2x equals, so pi minus pi on 2 is pi on 2. Okay, 2 pi minus pi on 2 is 3 pi over 2. 3 pi minus pi on 2 is 5 pi over 2. And 4 pi minus pi on 2 is 7 pi over 2. Okay, now what I'm going to do is I'm going to divide each of those values by 2. So this becomes pi over 4. About to write 2 again. 3 pi over 4. 5 pi over 4. And 7 pi over 4. What you'll notice is now that we're back to our original value, all of these coordinates that I found are actually within my original domain, and that's what I wanted. That's why we sort of had to expand the graph and then we shrink it back to find our coordinates, okay? And that's kind of what we're doing. There's a lot of manipulation around it. So what we actually have is we've found all our x coordinates, okay? We've got our starting point for our y's, okay? And we've got our values for our minimum, okay? So what we can do is we can actually start sketching now. So what I'm going to do is I'm going to draw a graph here. Hopefully everybody is using a ruler, unlike me. I'm going to draw it as straight as possible. It's very wonky. Bear with me, it's not as easy as you think. Okay, so what we said, we've got a couple of coordinates that we had at the start. Remember when we said x equals 0? So I actually have a coordinate of 0, negative 3. Okay, so that's my first value there. So that's our starting point. Okay, I'm going to list that as 0, negative 3. Okay, that's a 3. And what we've got is when I bring this up, okay, so this is obviously at its minimum. So this is going to come up and we're going to get our first coordinate. Our first x-intercept is what we found there, pi on 4. Okay, so pi over 4. When this comes up and down, okay, that next coordinate will be 3 pi on 4. When it comes down and up, that will be 5 pi on 4. That comes up and down, that becomes 7 pi on 4. Okay, so we found our 4 coordinates. Okay, so we've got a little couple of crosses there that I'm going to put there, 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 and there. Very similar to what we predicted earlier. Okay, we only have 4 of these. And remember our final value. Okay, our final value we found was -3, so that's actually at a coordinate of 2 pi, comma, -3. Okay, so that's going to finish right down the bottom of where we had, and that value is going to be 2 pi, comma, -3. Okay, and that's how we draw our graph. Okay, so I've drawn my graph a little bit too big to what I predicted, but that's quite all right. Okay, please label your coordinate y, and if you want to finish your graph, that could be x. Okay, just ignore that whole section. Please take care. It will take a lot of practices, guys, so it is a reasonably difficult skill. Once you know how to manipulate the domain and generate all of your values, that's the hardest part there, okay? And then you can, the best thing about these true graphs are they're always symmetrical, okay? So what I mean by symmetrical, so that distances are always the same. So the distances between the 2 peaks are always going to be the same. The distances between each of the x-intercepts are always going to be the same. This point at the top, the maximum minimum, is always going to be right in the middle of those 2 x-intercepts, okay? So they're all a lot of symmetry about it, okay? So quite a bit of practice. If you get going with a few of the questions from this exercise, and hopefully you are going to go all right, okay? Thank you.